All right, this is 7.1 for trigonometry and 6.1 for pre-cal. This is called the law of sine, okay? So in this section, we're going to learn law of sine, and in the following, we're going to learn law of cosine. Now, in the past, we have learned SOHCAHTOA and Pythagorean to be able to work with triangles, but those two rules only work for right triangles. So with a law of sine and law of cosine, we're going to be able to find out different angles and sides of triangles that are not right triangles. Another word for that is an oblique triangle, okay? So these notes, these next two sections are specifically for oblique triangles. Whenever we're solving, our calculator has to be in degree mode. We will be using it often today. And then I want you to be able to create this setup every single time you're solving either a question, from either of the two sections, whether it be law of sine or law of cosine, okay? So from this chart, you're going to start off by plugging in what is given. They are always going to give you 3 out of the 6, and your job is to find the other 3, okay? Next, you're going to use the 180 rule. If you remember back in geometry, all 3 angles added up together should always equal 180. So if they give you 2 out of the 3, you can subtract those 2 from 180 and you can find the third. And then next, you're going to see if you have a match or not. What I mean by that is if you have both A's given or both B's or both C's. If you have 2 of the letters already given, that's when you know you can use the formula, which I'm going to show you next from this section called law of sine. If you do not have a match, let's say I have 1A, 1B, and 1C, that's when I'm going to have to use what I learned next lesson, which is called law of cosine. Okay? So the formula for law of sine says that there's a ratio between the side and then the sine of the angle. Okay? And you can set up that same ratio equal to any of the other letters. Okay? Now, I won't be using all 3 of these at the same time. So, for example, if I have both of my A's and one of my B's, then I can just use these 2 to solve for the missing B, whether it be the angle or the side. Let's say I have both C's given and I want to find one of the missing A's, and I only have to use those 2. You will only use 2 at a time. You don't have to use all 3 at a time. Now, this formula stays completely true if I reverse it completely upside down. My suggestion, you do not have to do this, but my suggestion, it's going to make your work a lot shorter, is that if you are looking for a side, which are the lowercase letters, you keep that in the numerator. So use this top one. If you're looking for an angle, which is the capital letters, then that's what you're going to put in the numerator. Okay, again, you don't have to. Whichever of these 2 you use, you will still be able to get the right answer. It just might take you a few extra steps. So again, rule of thumb is whatever you're looking for, pick that one in the numerator. Okay? So another reminder from geometry is that the letters will always be across from each other. So side A, lowercase a, will always be directly across from capital A. And the same is true with all 3 letters. So what I'm going to do to begin is to plug in what I know. So I already know that angle A is 20 degrees. I know that angle C is 45. And I know that side C is 32. So that was step 1. Plug in what's given. Okay. Step 2 is to use the 180 rule. Do I have 2 out of the 3 angles given? You see it? So that means to find angle B, I could say 180 degrees minus the 20 and minus the 45 will give me what angle B is. All right, when you plug that into your calculator, you should get 115 degrees. Okay, so that is the first answer that you find, 115 degrees. So again, I told you they were going to give you 3, and your job was to find the other 3. Okay. Next question you should ask yourself is, do I have a match? Do I? Yeah, you see how I have both C's given? That means I'm going to be able to use both C's to find little b, and I'm going to solve for that. And then a separate thing, I'm going to use both C's to find side A. Okay? Now, since I'm looking for the sides, I'm going to use the formula that has the lowercase letters on top. So I can say let's say I want to find little b first. I'm going to put little b over sine of angle B. Angle B is 115. And I'm going to set it equal to the one that I have both given. Now, if I started by putting the sides on the top, I need to finish by putting the sides on the top. So side C is 32 over sine of angle C, which is 45. Okay? Now, all I have to do here to get little b by itself is multiply this sine of 115 over to the other side. So now I have little b is equal to 32 times sine of 115 over sine of 45. Now we have the luxury of plugging that entire thing straight into our calculator, and it'll give me what side B is. Okay? So hopefully if you took a moment to put that in your calculator, it should look something like this. Again, you can see at the top I'm in degree mode. I just put the function that we had set up, and it gives us 41.014. Okay? 41.014. And that's little b, so I'm going to plug that in right here. And I'm going to do the same exact thing for little a. Okay? Now, a lot of people ask me if they can use, being that they have a match with b now, if we can use b to solve for a. Technically, you can, but I'm going to give you two reasons why not to. Reason number one is in the chance that you made a mistake somewhere here and you got little b wrong, it'll automatically get your little a wrong. Okay? Reason number two is that this little b, you rounded to get this point. So since you're using a rounded value, your answer for a is going to be a little off. Okay? So I always suggest to use whatever values the question gives you. So now I'm looking for little a, so I'm going to put a over sine of a, which is 20, equals, and I'm going to use c again, so 32 over sine of 45. Now we're going to take this sine of 20 to get little a by itself and multiply it over. And I can say that a equals 32 times sine of 20 over sine of 45. And now notice if you had just done b in your calculator, the only thing that changes here is instead of sine of 115 in the numerator, it's sine of 20. So instead of retyping the whole thing, scroll up, press enter, and change that 115 to a 20. And it should be a lot faster. So if you're on your calculator, I'm going to scroll up, press enter, change that 115 to a 20, and press enter. And you should get that a is 15.478. All right. And with that, we have finished filling out all of our blanks. And we're done with this problem. I'm going to give you guys a minute to solve this bottom one on your own, and then we'll come back and fill it out. All right, so for this setup, it might initially look like you don't have a match, but that's why in the notes earlier up, I have you use the 180 rule first. If you use the 180 rule, you should get that your third angle is 74 degrees, okay? Once you find the third angle, you do have a match, which makes this a lot easier, and then you can start your setup. So let's say we are finding side A first. I put a over sine of 34 equals my match, which is 70 over sine of 74. Multiply that sine of 34 over. And before I go to my calculator, just so I do all of my written work at once, I'm going to do the same exact thing for little c. Okay? So little c over sine of angle c, which is 72, is equal to, I'm going to use b again, so 70 over sine of 74. Multiply this denominator over, so I have c equals 70 times sine of 72, a lot of sevens here, over sine of 74. Bless you back there. Okay. So now we go to our calculator with both of these. Okay. And here's our first one. Let me put this a little higher. Okay, you should have gotten 40.720 on the first one, and then 69.256 for the second one. Okay. And somebody asked me this in class. I have a habit of writing 3 decimals after I teach AP Cal, and that's called truncating. And an AP Cal test, they give you full credit for writing your decimals like that, whether you whether you round, thank you, or not. Okay. And we are done with this problem. All right, for these next questions, although we will still do the setup, they are only asking us for one of the sides. So I'm going to take a moment and do my setup. Fill in what I know. But the only thing I have to take a moment to solve for is A. Okay? Oh my gosh. No, it's recording, guys. I apologize for those technical difficulties, but we're back. All right. So, even though you might get used to in your homework filling out the entire chart, be vigilant if the question just says to find one side. Because do I need to even take the step of the 180 rule here to find side A? No, I already have a match, and I already know the angle for side A. If they were asking me for B, then I'd have to take a moment and do the 180 rule. So kind of analyze it and don't overwork yourself for no reason, okay? So I can say I'm looking for the side A over sine of 35 equals side C over sine of angle C. Okay? Multiply that sine of 35 over. And you're going to plug that into your calculator. All right, when you plug that in your calculator, you should get 12.27. And again, they only wanted side A, so that is where I stop. I am done there. Take a moment, pause the video if you have to, and solve for the second question on your own. So let's take a look at this last question. When solving it, do I have to take a moment to do the 180 rule? Yes. What did you get for angle B? 68. Very nice. So you should have said 180 minus 25 minus 87, and you should have gotten 68. Now they want us to find side C. Okay. So now I have a match with B. I don't need that A anymore. Okay. So I could say little c over sine of angle C, which is 87, equals the match that I have, which is 14 over sine of 68. Multiply that sine over. And then what did you guys get for little c? 15.078. And again, they were looking for side C, so that is your final answer. Okay. All right, and now we move on to this word problem here. All right, so let's start off this question. It says that two fire lookout towers are 17 miles apart. Okay, so I'm going to start drawing here. They're 17 miles apart. Okay, it says Tower A is directly west of B. So if we remember, north, east, south, and west. West means something is left. So that means this is Tower A and this is Tower B. Okay, now it says that they both spot a fire up on a mountain up north. Now I'm going to draw a triangle that just to my best guess, but we really don't know where this fire is. So let's say our fire is here and they both spot it. Okay, so here's our fire. Now it says the bearing, be very careful, this is some old info here. The bearing from station A to the fire, and let me do this in a different color, is north 55 degrees east. So at A, I'm going to draw a little bearing. We have north here. Remember that bearings always go from the first letter, so from north towards east, and this is 55 degrees. Okay? And then it says that from station B to the fire, so now I'm going to draw another bearings here. It is north, and I'm going to travel 40 degrees towards west, meaning towards my left. Okay? So be careful because the trick here is that a lot of people think those are the degrees we're supposed to put in these spots. Okay? But in reality, what do I have to do to be able to find angle A? Subtract from 90. So I say 90 minus 55, which gives me 35, is really what this value is. Okay? And then same exact thing for B. It's a bearing, so I'm going to say 90 minus the 40 degrees, and that gives me 50. Okay? What can I do to find my third angle over here? The 180 rule. Beautiful. I'm going to call that angle C, which means I can say that this is little c. And I can say 180 minus 35 minus 50 is going to give me 95. So now I can start my chart. Okay? I could say A is 35, B is 50, C is 95, and from my sides, the only one that I have is little c. And again, I determined that that 17 miles was going to be little c because it was across from angle C. Okay? So now the question says, how far is station A from the fire? So follow my pen. Station A to the fire is this line right here. Who is this little line across from? B. So who am I really looking for? I'm really looking for little b, and I don't care about little a because I'm only wondering how far is station A from the fire. Okay? So you see I have a match, and I'm looking for little b. So, whoops, b over sine of b equals the match that I have, which is 17 over sine of 95. Multiply this sine of 50 over. and plug that into your calculator. All right, so if you plug that in your calculator, you should have gotten 13.072. And then remember, they had told us that the units was in miles, so this is how many miles away Station A is from the fire. All right, so this next word problem, I'm going to skip around a little bit in the PowerPoint just to do the two word problems together. Talks about a river, and then they use a device to measure these angles. And they want to know the distance from person A to person B standing across from the river. Okay, so if I want to know the distance from person A to person B, what am I looking for? Good, I'm looking for this side, which is across from angle C, which makes it little c, side C. So make yourself a side note that you are looking for side C. Okay, so I'm going to set up my chart. A is 58 degrees. B at the moment is unknown. C is 69 degrees. Little a is unknown. And little a we are not worrying about. Little b is across from angle B. So little b is this 500. And then little c is what I am looking for. Okay. I promise you, a lot of these textbooks, guys, if you ever go to the textbook, talks about, and it's probably some bad memories from geometry, SAS, SSA, all those different acronyms for what type of triangles they're giving you. If you fill out the chart, you do not have to worry about that at all this chapter, okay? So, step one, do I need to do the 180 rule? Yes, I do, because I need to get my match with B. So, for capital B, I'm going to say 180 minus 58 minus 69, and that gives me 53. Okay. Now I have my match that I can set up to solve for little c. So I can say little c over sine of 69 equals side B over sine of angle B. Okay. I'm going to multiply this over to get little c by itself. So I can say c equals 500 times sine of 69 over sine of 53. Okay, go ahead and plug that into your calculator. All right, and when you plug that in, you should get 584.484, and my units was feet. Okay. All right, so the last thing for this video is we're going to do area of an oblique triangle. Now, I know you visually see three formulas, but it is the same formula. I wrote all three out just for your eyes. The area of an oblique triangle is half times two sides times the angle in between those two sides. Okay? So, this only works for triangles that are given, and of course, you don't have to memorize this, but side, angle, side. It's the two sides and the angle in between them. So, if I ask you for the area of this question, which of the three formulas do you think I'm going to use? The first one. Not that you have to, again, know the difference between them, but as long as you see that the angle is in between the two sides, I can say that my area is equal to half times the two sides times sine of the angle. Oops. Oh, a little dyslexic apparently. Let's wrote that backwards. Sine of 71. Okay? And you can go ahead and plug that straight into your calculator. And what do you guys get when you plug that into your calculator? Beautiful. 14.182. And then those two little marks next to my 6 and 5, what does that mean? Inches. So you can put the two little marks again, or you can write the word inches. And that is it.